The International Space Station took 10 years and more than 30 missions to assemble. It is the result of unprecedented scientific and engineering collaboration among 5 space agencies representing 15 countries. The space station is approximately the size of a football field, a 460-ton, permanently crewed platform orbiting 250 miles above Earth. It is about 4 times as large as the Russian space station Mir and 5 times as large as the US Skylab. The idea of a space station was once science fiction, existing only in the imagination until it became clear in the 1940s that construction of such a structure might be attainable by our nation. As the space age began in the 1950s, designs of space planes and stations dominated popular media. The first rudimentary station was created in 1969 by the linking of 2 Russian Soyuz vehicles in space, followed by other stations and developments in space technology until construction began on the ISS in 1998, aided by the first reusable spacecraft ever developed, the American shuttles. Sustaining a permanent environment in space. Sustaining a permanent environment in space requires things many of us take for granted here on Earth: fresh air, water, food, a comfortable and habitable climate, even waste removal and fire protection. First, let's talk air. We all need oxygen, so the ISS has several methods of providing it. One technique is to have oxygen delivered from Earth via spacecraft. Supply shuttles periodically arrive with fresh oxygen in tow. The life-giving element is deposited into pressurized tanks aboard the ISS. The ISS also has systems that make breathable oxygen from recycled water. Using electrolysis, some of these devices split water into hydrogen and oxygen gas. So what about food? Well, apart from some edible plants that are grown on board, the crew depends on routine deliveries for most of its food supply. Lots of menu items come in specially designed packets that get affixed to dining surfaces with Velcro, lest they float away in the low-gravity environment. Maintaining a habitable temperature is another big concern. The ISS has to withstand temperatures of -128 degrees Celsius or -200 degrees Fahrenheit and 93 degrees Celsius or 200 degrees Fahrenheit on the dark and sunlit sides of our planet, respectively. Among other things, the ISS uses heaters, insulation and liquid ammonia circulating loops to regulate the internal temperature. Radiators help release excess heat generated by some of the machinery aboard the station. Like any home, the ISS must be kept clean. This is especially important in space, where floating dirt and debris could present a hazard. Astronauts use various wipes, detergents, and vacuums to clean surfaces, filters and themselves. Trash is collected in bags, stowed in a supply ship and returned to Earth or incinerated. Fire is one of the most dangerous hazards in space. During astronaut Jerry Lininger's stay on Mir, a fire broke out. The Mir crew extinguished the fire, but not before the station was damaged. To detect and suppress fires, the ISS has smoke detectors, computerized alarm systems, fire extinguishers and portable breathing devices. The ISS is basically a large spacecraft. As such, it must be able to move about in space, its crew must maintain communications with controllers on the ground, and it needs power to accomplish all of this. We take for granted having electrical power to operate our homes. For example, to use your coffee maker, you simply plug it into the wall without a second thought. Like in your home, all of the onboard systems of the ISS require electrical power. 8 large solar arrays provide electrical power from the sun. Each array is 240 feet long, and cumulatively speaking they cover an area of around 27,000 square feet.